Okay, now let us start from the beginning once again. See, for a telescope we have two lenses. One is objective and the other is eye lens. Now, objective has a large lens and eye lens is a small one. Only to gather more information, more light. If it incidents, we get more information. That is the only reason behind it. Now, the focal length of objective is of f1 and focal length of eye lens is okay. And now here we are taking two rays. These are the two rays. Now a ray passes through optic center goes undeviated. So to be frank, it has to go from the center actually. Okay. So optic center goes this ray goes undeviated. The second ray bends and meets at the point. Okay, A dash. This is A dash and B dash. Okay, and H is the height of the image. Now this image is acting like an object for the eye lens. So we can take 2 rays, 3 rays, how many? It's up to minimum 2 are enough. But this was not given, this is given, these 2 are given in the book. So for my convenience, I took first this and this one. A ray which passes through optic center goes undeviated. Second ray, which is parallel to the principal axis, it passes through the focal point. Okay. Now, so what is the magnification formula now? Beta by alpha. What is beta? Tan beta by tan alpha. That is h by f and h by f. This and this will get cancelled. Fo by f will be remaining. So L is equal to what? Fo plus f. That is the length of the telescope tube. Okay. And alpha is the angle subtended by the object. Beta is the angle subtended by the image. Okay. I will tell you, like suppose when you are using the telescope, this astronomical telescopes or terrestrial telescope, even 1 minute. What is 1 minute? Like 1 degree.
Oh yeah, 1 degree.
1 degree. What 1 minute is equal to 1 by 60. Okay, 1 by 60 degree. Yeah, or 1 by 60 of the degree. Okay, I write like this in this. Okay. Yeah. So that will give 1 minute. Again, 1 second is how much? 1 second is
1 by 60.
1 second is 1 by 60 minutes. Okay. This can be written like this: 1 by 60 degree, and that is 1 by 60 minutes. So divide it. So means 1 degree is how much? Suppose when you circular scale, suppose this is your protractor. This is your 90. Yeah, 10 may be this much, right? 1 may be this much. Again, in that 1 minute, you divide that 6 into 6. That slight variation, you cannot see the star. Even 1 minute variation, you are out of the whatever the field, out of the field. Understood? So that's so precise are the telescopes. Even microscopes also. Telescopes they are very precise. You will be seeing, suppose you are doing an experiment and your friend hit you or he pushed you. Then what happens that it is out of the field. Now you have to struggle to bring it again to the normal. Yeah. And have you seen in the telescope and microscope there is a crossfire? Crossfire.
Yeah.
The gun also there is a crossfire, right?
Okay, yeah.
This is said to be crossfire. Crossfire. Why is it crossfire? The focus to the center. Okay. What is this actually? Is it a line?
I think it's engraved on the lens.
No. What do you think, Mr. Ram?
What is it?
Huh? Is it a line?
Maybe.
What do you think, Mr. Ram?
Point.
Like there is a line, like.
Yeah.
So what is it actually? Yes, sir, the middle line from the A dash is it parallel to the principal axis? No, it is not parallel to the principal axis. It is. I have taken a line between both of them. So I want to respect the textbook. That is the reason. So I drew one more ray. Okay. Clear? Yes. It is the hair of a horse.
There was a sticker in this book.
Yeah. Hair of a horse is very thin and it is very stiff. It is used in medicine also. Sometimes some people get a small like moles. It will come on the skin, black color skin. What they do is doctors, they tie a knot on that and stretch it.
They stretch it so it
That will
comes
come out without any puncture. The old way of removing that, like some people have on the neck or near the eye or something like what black color thing. I don't know what is that called.
Yeah, and then there's one hair sticking out of it.
Something like black color thing which is little. Sometimes it will become bigger also. It's like a actually unwanted blood, I think, because of that it forms on the body. So they remove using the horse. What is it? You know, the horse thing. Okay, the hair. They put it on, pull it, finish. Best way. Okay, without because it doesn't got and it is antiseptic.
cool.
Okay, otherwise if you cut with a blade, you have to
Yeah,
put on
yeah, yeah.
septic. It is so that won't happen. So that's a advantage. Okay, so yeah. So there is one of my professor told this one. Even we didn't know about it. We're also thinking it's line, something like fine line. I don't know. Then I touched and saw that one. I removed the eyepiece and saw really very easy, like lying or then we came to know yeah, it is really a hair. Okay. Yeah. Okay. Now that's an answer. Yeah. Oh, what was the question? The question was like there is a crossfire right in the telescope or microscope eyepiece. There is a crossfire. So what is that wire made of? That was my question. Got it? So answer is here. The horse. Okay.
But imagine I asked this for 2 marks in exam.
No, they will. This is for information. Okay.
So if they ask an exam, I'll get full marks. Horse.
Yeah. They know because that is not there in the syllabus, right?
They should put this kind of stuff in syllabus. It's more interesting.
Now, no, in electrostatics also we study about the electrostatics, but no examples are given actually. Electrostatics, yeah. Electrostatics first chapter. We were studying like that friction, conduction, and induction.
Oh yeah.
The best example of what we are just photocopy machine, aeroplane landing. You know, when the aeroplane land, what happens? Actually, due to friction, what happens? The car, when we are traveling a long distance, due to friction, sometimes you touch the car and you get a shock, right?
Yeah.
Yeah.
Started.
Yeah, you get a shock. It is because of the friction. Okay, because of the friction between the air and the car door. Okay, that happens. So that happens with the aeroplane also because it's running very high speed. So many charges are formed. So how do they remove this one when it lands? It lands right.
Yeah.
So it has so many charges. So suppose if you take some rod or bridge
So it will be
something, if it
negative.
immediately
It will be negative charge, right? Then I think they put it all in the tire and then
they just put it like this. Earlier, the older one they used to the outside on the ground stuff. He used to put a rod like this. So all the charges on the body will go to the ground. The old technique, but new technique is different. How? Did you see that when the aeroplane touches the runway, you get sparks. You see the sparks.
Yeah.
Oh, so the wheel has it?
No, the wheel is made of rubber, right?
Oh yeah. So then there's something.
The
runway.
wheel is made of rubber. It's an insulator. There should be something, no? So what exactly happens is now the aeroplane wheel, how it is, on the surface of the wheel you have metal strips.
Yeah.
These metal strips, no, from the body. Suppose this is the aeroplane body of the aeroplane, and suppose this is the wheel. Okay, there is a metal brush connected from the body to the wheel. So the time it touches the ground, all the charges which are on the body will go through this brush, and then the metal brushes are touching the wheel, and then whatever all the charges will go to from this metal. Got it? So that is how immediately within 1 or 2 seconds all the charges are discharged. We are fairly safe. Okay, so that is how it works. So that is why they immediately, and also when takeoff and landing also they close immediately, right?
Yeah.
So this was about telescope. Any doubt in this, Mr. Yeah. Okay. Yes, Mr. John and Joshua. Is it clear this experiment? Yes? Okay. Now, I have to explain you red shift and blue shift, which is, was it there in the first one? No, it should be in the second one. Red shift and blue shift. Red shift and blue shift. We did here this one, red shift and blue shift. Okay, this is something interesting. Okay.
But is it in the chapter?
Huh?
Is it in the chapter?
It was there, I think. I don't know. I never was followed, but that is deleted.
Wavelength of the
I did not teach that also. Scattering
wavelength of light.
I also did not teach.
I is also there.
I is deleted, no?
Yeah.
I hate the
This is the easiest one, no? Why do you hate?
Sir, because in 10 my eye diagram is always so bad.
So that is the reason you hate.
Yes, I practiced so many times. I think it came in board exam, so 100% I am sure I lost marks in that. Maybe wave optics.
It is in, yeah. Somewhere I have seen that question.
Oh yes, it's in wave optics. The
Wavelength
wavelength
and
of
all
the
is in wave optics.
yeah.
Yeah,
The
here it is.
wavelength
The
of
Doppler
the
effect. This is deleted actually.
yeah.
Okay, let me explain because we are discussing the telescope. Let me explain the redshift and blue shift. It is very interesting. That's not given in the book. Anyways, so we say redshift and blue shift. This comes under Doppler effect of Doppler effect. We have Doppler effect studied in sound, no? Sound Doppler effect in sound last year because that also was deleted. In waves, we have simple oscillations. After that, waves.
Yes.
In waves, the last topic was Doppler effect.
I saw it.
That was deleted.
Yeah,
That was deleted. So that was Doppler effect in sound and Doppler effect in light. So two cases are there. Okay. Now, so this is redshift. Redshift. Suppose you are focusing on a finger on a star. The telescope is you can focus on the star. Now suppose he is an astronomer, scientist who is like interested in the stars. Okay. So they are focusing on a particular star, maybe a bright star. Now what happened is the star which we see today is the star light emitted by the star 4 years, 3 months back. Understood?
Because light takes time to travel.
That much far it is, you can understand now. And the sunlight, it takes how much time to reach the ground? 8 minutes 20 seconds.
Yeah.
8 minutes 20 seconds for the sunlight. Whereas for the star, 4 years and 3 months. Okay, which we see today. So, like suppose what happened, because it is a white color light, that light is made to pass to the telescope for the eye lens, and we keep the prism over there, and it disperses that light into 7 colors, and we see the some spectrum on the photographic plate or on the screen. Okay, good, well and good, that's good. Now let it be like this with GR colors. Is that clear? Now what happened is we want to know whether the star is approaching the earth or moving away from the earth. Here we want to read about that. Now suppose all the lines are very close in this way. What is the meaning of this? With GR. All the lines are shifted towards the red color light. And here all the, suppose maybe after 3 years or 4 years you saw this star again. You are focusing. Earlier we used to do manually, but now we are not doing manually. We used to connect the telescope, then prism, then photography, then screen. Now it is not done like that. Now it is connected to the computer. There is just analyzer. So the computer will do it now. So computer is doing everything. So it will record all the data. Okay, so that is doing, like NASA and all, we have supercomputers for that. We are doing all this. They are deriving the information for that. Now, now here it is toward the violet color or blue color. Okay, violet or blue color. So this is said to be red shift, and this is said to be, this other one is said to be blue shift. Okay, red shift and blue shift. Okay, so red shift means the star is moving away. Why? Because the wavelength is larger. And here the wavelength is smaller.
Smaller.
That means it is the cause of concern. Yeah. the star is moving towards Earth, is a cause of concern. This is how we study for meteorites also. The stones or rocks which are falling on the Earth. They study the same way. Understood?
That's how we know when the meteor.
Understood now? These are all optics. Redshift and phase. Yeah. So this is studied using the Doppler effect phenomena. Got it? Okay. So okay. We'll go ahead. Okay, this is not it.
So if the meteor comes also, what can we do?
We cannot do anything, but we can like we have done before. Like like NASA when it got the information, the US targeted a missile on that.
Yeah, so that it can break
Then it
into
got
small
developed.
pieces, right?
It was made into pieces. But like in the atmosphere, when once it reached the atmosphere, not in the space. If it is in happening as well, it will be big problem there is. If the pieces can go to even hit the satellites or the space shuttles and all. So they didn't do that. They were waiting for that meteorite to enter the atmosphere. Once it entered the atmosphere, they targeted the missile and they blasted it into pieces. That was it. Okay. Yeah. Now, next one, last one is Cassegrain telescope or reflecting telescope. Reflecting telescope. Draw like this and remove this part. Now, reflecting telescope or Cassegrain telescope. There's a what is this mirror? The big one. Concave mirror. Okay. This is a big concave mirror. Now, light is made to incident on that. Now, like small region is removed. This small region is removed at the center, and we place the telescope. Okay. And the ray will incident from the power object onto this mirror, and they are reflecting back. Where? At the focal point. But before the focal point, maybe this is the focal point. Example, this is the focal point. Okay, but before the focal point, there is a one more mirror. What is it? Convex mirror. So it will diverge. Okay, so actually maybe the rays would have come like this. Okay, they would have met like this. So they diverge and they meet at on the eyepiece. Okay, they meet at eyepiece. So that is how the image is formed. But there is advantage and disadvantage. What is the advantage?
So this is like it meets exactly at one point, so we can notice it more clearly. I guess
Yesterday I was saying something.
there's no error.
There's no aberration.
Aberration.
Yes.
Okay. Okay, the aberration because of reflection, because of mirror loss, chromatic aberration is removed actually.
In lenses.
In lenses there is a chromatic aberration, but in this mirrors the chromatic aberration is not there. That's the advantage of that. First thing about that. But problem is it is not, you cannot carry from one place to another place. It has to be installed for the lifetime. Okay. Okay. You have to, this mirror are very big. They are
Very bulky.
very big. I told you, no, the biggest one you can play, like someone was saying, what is the diameter?
China.
The China one.
The
How big it is?
7 kilometers.
7 kilometers, yeah. That's so big. Very big, you know. Now, if you see the reflection, the mirror is very, very huge. Very, very huge. You can play even football on that. That's how big it is, yeah. So, okay, that is one disadvantage. You cannot carry from one place to another place. One more disadvantage is, you might ask, sir, will this not hinder that proper full information? Because it is coming in between, right?
The light rays.
Yeah.
I don't
This-
think it will.
Like a big mirror is there. You kept something, light is coming from there.
Yeah, but
A
it will
big mirror is there, and a small.
it will blur it a little bit, but not
completely, right?
Yeah.
Okay, maybe 1% variation may be there in the quality of the image. And the images, and also because this mirror is exposed to the sunlight or air and all, it gets corroded.
Oh.
It gets corroded because of, we have to keep on cleaning it. Maintenance
Yeah.
is very, very important. Otherwise, because of the mist or fog and all this, it gets
Yeah,
spoiled.
correct.
Mirror is having this headache. Lenses, you can directly clean it. Lenses, you can put, there is a lens cleaning liquid with the clean that we clean it. Okay, this is also a problem with that. And also, if you see practically when when we are doing this, it is somewhere in India also, and also somewhere in Mount Palomar telescope in California. This one, it is how much? 200 inches. The diameter is around 200 inches. This around 5 meters diameter. So big. And also the person will go and sit in the cage over there. Yeah, literally, that's a big. He'll go and sit in the cage to see the image. Okay, they are huge. They are very huge. Okay, so reflecting and both have their advantages and disadvantages. Okay, refracting will have disadvantage, that is chromatic aberration problem. Okay, chromatic aberration problem. Okay, so so here we have in India also they have given a place, that is what Kavalur. It is 2.34 diameter reflecting telescope. Okay, and also in Bangalore also IIT, Indian Institute of Astrophysics, Bangalore also we have this one. Okay, and Hawaii, he said this is old information. Reflector 10 meter in diameter in Hawaii, USA. Okay, there is one more telescope whose this reflector is around 10 meter in diameter. Means 5 meter in radius. That's how big it is. But we have more than that now. This book was printed somewhere in 2005, I don't know. Okay, but after that, many changes have taken place. Don't go with this information, but recent advances, Like very big telescopes are there. One in China, one in Mexico, USA. They are big, and also they are based on the big mountains, so that the field view will be clear. That's all. Because no field view will be clear and there is no disturbance at all. Okay. So that completes your lesson. If you have any doubts, you can ask me. Turn the pages and see if you have any more doubts.
So, but if they're kept on the mountain, like they're kept higher, and the
Huh.
clouds doesn't block the view.
Large
Won't
model,
the
like suppose an
light
example, uh, we take, Everest mountain, Mount Everest. Generally, the clouds are below, like, when you're moving up,
Yeah, the clouds are actually below.
actually below that actually. Understood? So they want to go above the clouds. That is
these
the,
normal compound, sorry, not this, the normal telescopes. So, yeah, refracting telescopes, they are on ground, right? On
the
ground.
terrestrial one, yeah. Terrestrial means we can use it.
So still, won't the light be like a little bit, you know, won't there be more aberration because of the cloud?
No, refracting is you can use it. Right? There can be, yeah, it can be. So that's possibility is there. Okay, possibility is there. Here also in Sharjah also it is there. In Sharjah University, there is a lab it seems. There is astronomical laboratory they made. So you can even go and work, but I don't know whether they will allow or not. Okay. In India, like in Jantar Mantar in Jaipur, I think, biggest one is there. Very old one and the biggest one is in Jaipur, and then one is in Delhi, and one is in Andhra Pradesh. Like that, we have so many labs, astronomical laboratories are there. So whenever there is something happening in the sky, that those labs are open. You can go and see Jupiter or Mars or those so and so stars. Okay.
So I was asking, and won't the light rays also like refract when they enter the atmosphere? Like we learned from space to
When the
atmosphere.
light is coming from the
Atmosphere
space.
is denser.
Yeah,
So there'll be
Already
refraction.
refraction.
Yeah.
but when the light is traveling from it's traveling from vacuum to the atmosphere, right?
So
Yeah,
refraction
refraction
will
took
be.
place already. So filtration happened. That is ultraviolet light was blocked already. UV rays are blocked. Only there we have IR and visible rays, and in that also there can be scattering again. Many things are
Many
there.
things can happen.
Like you cannot say like it's pure because there are so many things are happening. The scattering is also happening. Okay. As suppose scattering is also happening, maybe refraction in the space is also happening. So okay, that is only 1%. That's only not more than 1%. That won't, will not damage the complete 100% quality of the image. Understood? Okay, so you'll get some image. Okay, right? You won't get like suppose example in in the scanning, ultraviolet, that is ultrasound scanning. Ultrasound scanning is again you have A scan and B scan. The ultrasound scan is not giving 100% information. Actually, X-ray will give the 100% information, but X-ray cannot be used for a pregnant child. Yeah, for the picture of the baby, to understand the information of the baby, we cannot go with the X-ray. Very harmful for the baby. It can go for abnormal growth. Also, it can go for the mutation or something will happen. So for that reason, what we are doing is we are only taking ultrasound. It's not giving that much clear picture. Still, you can use that information. Yeah, that is the way we use. That much information is enough to study the details. Got it? So everywhere you have advantages and disadvantages. Understood? But you cannot say, sir, can I design a camera with only